right, hi guys. So what we're gonna do in this video is we're gonna go over the practice problems on writing rational function equations. So if you've not already tried these problems yourself, please stop this video, go ahead and try them yourself first after having watched and gone through the notes yourself first. So that you get a chance to try them before going over them. Remember, the key to understanding math is to do math. You cannot learn math passively. Okay? But if you've already done that, you've already tried the problems, and you just want to see how you did or get some explanations, continue on listening. So here we go. So we've got our two standard forms of the rational equations. This is with the transformations of 1 over x as the parent function, and this one with 1 over x squared as the parent function. And so it says to determine the asymptotes, the domain, and the range of the graph, and then write the equation of the function. So the nice thing here in the practice problem is the vertical and horizontal asymptotes are actually already dashed in there for you. So the vertical asymptote in this case is x equals -2. And the horizontal asymptote has not changed from the original parent function, y equals 0. So this is a transformation of the parent function 1 over x. So the domain is x does not equal -2. And the range, again, for 1 over x transformation in this case would be y does not equal 0. This equals dash is how you're going to see it on your practice quiz and your quiz for this week, and it was the same last week. And so when you're writing the equation, what you're looking for here is the HK point, the point here where the two asymptotes meet. That point is at -2, 0. That's your HK. So your equation here would be y equals 1 over x minus h plus k. And when you simplify, that's y equals 1 over x minus -2 is x plus 2. And then you don't need to put the plus 0 there because it's a 0, so that can go away. So that is number 1. For number 2, again here you have the asymptote sort of drawn in for you. It's hard to see when they're on an axis, but the vertical asymptote here has not changed. It is still x equals 0, same as the original parent function. Where the horizontal asymptote here has changed, now it's y equals -2. Now this particular equation is a transformation of 1 over x squared. It could be really helpful for you to actually have the graphs of 1 over x and 1 over x squared with you as you're working through these problems so that you can easily see which one is a transformation of. But this one is a transformation of 1 over x squared. I can tell because both of my branches are here above the horizontal asymptote. So that does not affect my domain. My domain is still x does not equal 0, but it does affect my range. My range is not going to be y does not equal -2. Instead, it's going to be y is greater than -2. So keep that in mind for transformations of 1 over x squared. And then for the equation, we want to find our point where the asymptotes intersect. That's right here at this point, 0, -2. So that's going to be our HK. So the equation is y equals 1 over, and this is 1 over x squared parent function, so there's going to be a squared here. X minus 0 plus -2. So when I simplify, I get y equals 1 over x squared minus 2. And that is my new equation here. For number 3, we want to go back. Now in this case, this is another transformation of 1 over x, not 1 over x squared. For our vertical asymptote here, it has been shifted. We can see that the new vertical asymptote is x equals 2. The horizontal asymptote here has also been shifted. We can see that the horizontal asymptote is y equals 1. The domain is x does not equal 2, and because this is a transformation of 1 over x, not 1 over x squared, the range is y does not equal 1. And then when we're talking about the equation itself, we're looking for this point right here where the asymptotes intersect. That point is 2, 1. That is our HK. And so the equation here is y equals 1 over x minus h plus k. And it turns out in this case that is as simple as you can make it. That is completely simplified there. Moving on to example or practice problem number 4. This is another graph where it is a transformation of 1 over x squared. So the vertical asymptote here, again, you can see, and this actually turns out that this is the same as the previous example, but a different original parent graph. So the vertical asymptote here is x equals 2. The horizontal asymptote is y equals 1. The domain is going to be the same as number 3, x does not equal 2, but now because this transformation, because this graph has a parent function of 1 over x squared, not a parent function of 1 over x, that is going to affect the range. So the range here is going to be y is greater than 1, not y does not equal negative 1. Sorry, positive 1. And so for the equation here, we are looking for this point where the asymptotes intersect. It's again the same as our last example. It's 2, 1. So that's our HK. But now this is originally 1 over x squared, so 1 over x minus 2 squared plus 1. And just like our last example, this is the simplest that you can make that. All right, moving on to number 5, we can see that our vertical asymptote here, again, because they're nice labeled for us here, is actually on the y-axis, x equals 0. But then the horizontal asymptote has been shifted down, y equals negative 1, so we can see that. It's a little bit hard to see what the numbers are, but we can get it from that. The domain would be x does not equal 0. And the range, since this is a transformation from the parent function 1 over x, the range would be y does not equal negative 1. And then for the equation, what we're going to do is we're going to, again, find the intersection point of the asymptotes. So that is right here. This point is 0, negative 1. That is our HK here. So y equals 1 over x minus 0 plus negative 1, which when we simplify is y equals 1 over x minus 1. And then finally from this section, number 6. Now number 6 is actually slightly different from some of the other ones we've done. I don't think this was covered in our notes, but we'll talk about it now. If you have the branches in a different location, instead of being in quadrants 1 and 4, in this case, they're in quadrants 1 and 3, they're in quadrants 2 and 4. Notice how that is different from the original parent function 1 over x. What that means is that for your equation, Instead of being 1 in the numerator, it's going to be a negative 1 in the numerator. And so we'll get to that when we get to the equation itself. It does not affect the vertical or horizontal asymptote, nor does it affect the domain or range for a situation like this. It just affects the equation. So for the vertical asymptote here, we've got x equals 3, and for the horizontal asymptote, actually it's y equals 3. This is a transformation, even though it's been reflected. This is a transformation of 1 over x, so the domain is x does not equal 3, and the range is y does not equal 3. So when we're trying to find the equation here, we still need to find this intersection point here of the asymptotes. In this case, it's 3, 3, that's our HK. But because of the fact that the branches here have changed from 1 and 3 quadrants to 2 and 4, we have a negative 1 in the numerator instead of a positive 1. The a changes to negative 1. But everything else is the same, so x minus 3 plus 3. And that's actually, again, as simplified as I can make that. So if you do ever see a situation where the branches are sort of opposite facing, like you see here, that just means that the graph has been, in terms of transformations, the graph has been reflected over the x-axis, and all that does to the equation is changes the numerator to a negative as opposed to a positive. Okay? For the last section here, we're going to talk about how from the equation we can get the transformations themselves. So let's go ahead and do that. Here we can see that we've got this plus 4 in the denominator. The h is what has been altered here. Because it's plus, we always go opposite for the h value. So plus 4 actually means that the graph has been translated left 4 units. And then here, the minus 2 for number 2 in the denominator here, it's squared, but that does not really affect the transformation. All it does is affect what the original graph was. But because it's a minus, that means we're going right. So this is translated right 2 units. Here, the numerator and denominator have not, the denominator has not been altered. There's nothing been added on, but the numerator has changed from a 1 to a 3. And so that is going to mean that this graph has been dilated by a factor of 3. In number 4, we can see that again the numerator has been changed. Now the numerator is a 2. So this has been dilated, or a dilation, by a factor of 2. For number 5 here, we can see that there's actually 2 things happening. We've got a plus 4 in the denominator. That plus 4 means that the graph has been translated left 4 units. And we can also see that there is a minus 8 at the end here. When we're talking about the k value, that's up or down, and it's exactly as you'd think, not opposite. So this is translated down 8 units. And then finally, number 6, we actually have 3 different things happening here. We have first the 3 in the numerator as opposed to a 1, so that is a dilation by a factor of 3, or dilated by a factor of 3. We also have this minus 6 in the denominator for our h. That means the graph has been translated right 6 units. And then finally, we have this plus 4 here for our k. So that means that the graph has been translated up 4 units. All right, and then last question here, number 7. Look at the given graph. Jawan, I think that's how you say this, thinks that the equation of the graph is 1 plus 1 over x plus. Explain why Jawan is correct. Your explanation must include transformations. So there's just a couple of things happening here. First of all, you can see the horizontal asymptote. I'm not really sure why you can't see the vertical asymptote here, but let's go ahead and put that in. It's at x equals -2. And then all the other thing that's happening here that's a little bit strange is that we have this 1 here at the front, but it's the same thing as having it in the back. It's the same thing as having it over here. It doesn't matter where that goes. And so the key things here are that you have a horizontal asymptote at y equals 1, a vertical asymptote at x equals -2. And so the question is that the equation that you're going to have? And the answer is yes. So Jawan is correct because the equation and graph both show a horizontal asymptote of y equals 1 and a vertical asymptote of x equals -2. Keeping in mind here that the plus 2 here was originally a minus -2. So he is correct, and those are the transformations. You could also talk about, specifically for transformations, additionally, can also see the graph was translated left 2 units and up 1 unit from the parent function 1 over x. Therefore, the graph and equation match. So that is the idea here for number 7. So there's a couple different ways you can talk about it with asymptotes, with transformations. Yeah, that's the idea. So let me just make sure actually that you can see this. There we go. Okay. And so if you have any questions at all, please make sure that you ask your individual teacher. Hopefully this is helpful, and you have your practice quiz and your quiz for this week. Have a great day.